Hi everyone, welcome again to my presentation. My name is Suman Shah, and today I'll be working through my project, entire end-to-end project for Splunk multi-cloud deployment using Azure and AWS. This project is focused on building a robust, scalable architecture for log management and analysis. I'll be explaining the problem and aim to solve the solution, aim to provide the solution we implemented and result we achieved. So let's get started. Today, in a digital age, organizations generate massive amount of machine data from applications, server, IoT device, and many more. Managing these data is critical for operational insight like monitoring of the system performance, security including threat detection, compliance, reporting, threat intelligence, and scaling the infrastructure to handle growing data volume efficiently. But there are challenges: high availability, ensuring log management to the systems are stay online during the failures. This will help us to identify what was the root cause of the failure. Disaster recovery, quickly recovering the data in the event of system outage or a cyber attack or a malware attack where the data can get lost, where data there's a challenge with the data. So how we can get the disaster recovery, how easily we can retrieve those data. That is the one. The another one comes up the scalability of resource dynamically to meet our fluency data integration and query on demand. Security and compliance is one of the key challenges. Protecting sensitive data, adhering to the compliance, likewise GDPR, HIPAA, PCI DSS, and many more. We have European as well. So there are many more compliance requirements which every organization have to adhere while working. Typically, on-prem solution offers struggle with many challenges. The one which we discuss as high availability, disaster recovery, scaling, and security and compliance. My project is to address these issues by deploying Splunk across multiple cloud. When I say multiple cloud, I'm considering Azure and AWS, leveraging their unique strength to create resilient and secure multi-cloud architecture. Let me give you the overview towards the solution architect. So here, if you see my screen, the first thing is there, the primary side, the top ones on the top, these first stop I'm considering as the Azure, where the entire Azure deployment is the primary one, and the bottom ones is deployed into AWS. So when it comes to primary side, Azure, primary side, Azure hosts the Splunk key component like our indexers, which is responsible for parsing and storing of the data. Splunk Searchhead, which is mainly used by the user to perform query or to look for any specific data which they are looking for. Indexer Cluster Master is mainly responsible to manage these Splunk indexes so that they can perform data replication or data sync up with each other. These all data will get stored into blob storage. It is used for log archival, ensuring cost-effective long-term storage. We got a couple of Azure load balancers, if you see here. So these load balancers are used to manage traffic distributed across the component for high availability. Same when it comes to AWS. AWS environment is the mirror of our Azure deployment for disaster recovery. These all instances are deployed on EC2 instances, replicate Splunk indexers and Splunk searchhead. The same if I take in the green color, these are the replicated environment for indexer and these are the replicated environment for search heads. The next one, as the storage, we are using S3 for cross-region replication, providing secure data backup of all the logs. Integration between two Azure and AWS side, these two sites are communicating using Azure Express Route along with AWS Direct Connect, ensuring low latency secure data transfer. Splunk indexer clustering, these 6 components are ensuring the real-time data replication, maintaining consistency across both the regions or both the clouds. The goal is to achieve high available false tolerance or fault tolerance, secure log management during the unexpected failure. So going back to Azure setup, okay, so going back to Azure setup, here you can go and log into Azure portal and you can see these are the virtual machine we deployed on Azure for Splunk instances like our indexers, search head, and cluster master. I have set it up the load balancer to distribute these traffic, and this is being used for HEC, that is HTTP event collector. This ensures logs from various log sources can be ingested or integrated with Splunk smoothly. When it comes to AWS setup, over the AWS, we have configured these machines, these instances, as I said, onto EC2 instances, which are mirror of AWS environment, and S3 bucket is handling all the backup, cross-region replication, and data delivery. When it comes to Splunk configuration, in Splunk UI, you can see Splunk cluster configuration. In Splunk UI, you can see indexer cluster configuration, which replicates data between AWS and Azure, and dashboards are customized into real-time monitoring of these logs. Here are the couple of examples. We can see example of data ingestion on the logs. So logs from server, cloud, security tools are being ingested via our HEC event collector. These logs are getting forwarded to heavy forwarder for data annotation, removal of unwanted or unexpected data, and further it is getting stored into our Splunk indexer, which is mainly the log source where all the which is the storage for all the events and data source, whatever we are processing it to Splunk. For the disaster recovery, the same set of data is getting replicated on the other side, where 2 copies of individual data, index data, and 1 raw copy of each data is residing within the Splunk. And all these components are managed by indexer cluster master, and these licenses are getting monitored on license master, or all the configuration related checks are done on the monitoring console. So in the case of disaster recovery, if our AWS infrastructure goes down, these load balancer will start forwarding, sorry, over here, all this Splunk enterprise, this will start forwarding to the AWS internal load balancer through HEC, and these all data will get collected into AWS infrastructure. When when Azure infrastructure comes back, these data will start replicating. These indexes are keeping hold of data until the next or the other side or other cloud instances are coming back. Once they are back, they will start replicating the data with each other, ensuring all the data are replicated to both the sides so that user will not feel any latency or any experience with respect to not getting logs from Splunk. This entire deployment ensure the 99% of uptime for high availability, ensuring scalability of dynamic resource allocation. This will strengthen our security because all the data is getting stored into AES 256-bit encryption, and all the data transmit or data transit is getting transformed through TLS 1.2. So if you see here, all the communication within Splunk is happening on TLS 1.2. This project wasn't without its challenge. Here are the some key lessons which I have learned. So I have learned how to optimize the network latency, ensuring the low network latency between AWS and Azure, carefully thinking the Azure and AWS network configuration. Cluster synchronization, keeping Splunk component aligned across the site so that critical data and critical data consistency can be maintained. Security integration, configuring encryption, making sure RBAC controls and comply so that we can meet the compliance requirement as per the extra effort, but it worth to ensure robust security as well within the infrastructure. In the conclusion to this project, we showcase how multi-cloud deployment can solve critical challenges of log management and analytics by leveraging strength of AWS and Azure. We build architecture that have resilience, scalable, and secure infrastructure. When it comes to the component which we use during our deployment, so a couple of components we have used between AWS and Azure to bring a better environment. So all our indexer and Splunk Searcher are deployed on AWS and Azure. Splunk Enterprise deployment is on AWS and Azure. Apart from there, coming back to further, when it say all the compute is on Azure VMs, and on AWS side, it's on AWS EC2 instance. We are taking D or E series of Azure and M5 or R5 series within AWS. For load balancing, we have Azure Load Balancer, and on the AWS, we have ELB or AWS Elastic Load Balancer. Network is getting done by Azure VNet or Express Route. The same on the AWS services, AWS VPC or Direct Connect is being used. Storage is done on Azure Blob services, and the same on AWS is going through S3 bucket. All the logs are monitored through Azure monitors into Azure, and on the AWS, it's a CloudWatch. For disaster recovery, we have Azure Backup, and on AWS, we have Amazon EC2 cross regions. With that, thanks for watching my presentation. I look forward for any questions and to the response. Thank you, everyone.